Hello everyone. I would like to introduce a device to you today.
KT200
It's a
programmer
read-write engine ECU
and transmission ECU data. This device can support cars, truck, motorcycle, yacht, steamer. You see, your data reading and writing of these models, such as way of reading and writing, can be read directly by OBD. You can also read and write on ECU pins and supports checksum calculation function. So I'm going to show you how to use this device. This is the KT200 host adapter for KT200 BNCH box protocol. And then there's this read-write line. Power cable USB data cable. This is the OBD connector for the truck. This is a normal IBD connector. This is an operation interface of the KT200 generator software. I'm going to show you this. Read and write Mat 17.1 27 computer board for Volkswagen engines. First of all, in the software, we choose this option. It means manual. After clicking, you can find it here. The way we read and write on computers. And one of his read-write agreements. We just type in here the model of the computer version, Mat 17.1.27. This is the model of our circuit board. Then the model is Volkswagen. We choose Volkswagen. So what about in this interface? Can you tell us how we read and write? It's Mercedes-Benz, and then the agreement is TC1793, the model of our circuit board. Then a picture like this appears. That's when we wire at the right angle of the ECU. A pin chart for reading and writing. Okay, then let's close this one first. Then look in the software. In the software, we click to select the driver. Just told us to choose the bench mode. Then we choose this bench mode. Then choose the model Volkswagen. The protocol is TC1793 VAG. Then the circuit board model, it's Mat 17.1.27. Okay, we can click OK here. So here's an English music note. What do you mean? Even if you click on it, you will tell us directly. The computer version of the wiring diagram of this protocol you chose. The wiring diagram of this pin tells you directly. Okay, after we choose then click OK. After clicking OK, in this piece, we'll tell you the host needs to connect with this bench connection box. Okay, let's pin this ECU first. Put it on. We provide our wiring diagram according to the software. Use this recognizer. Then according to the color of this line, then plug it directly into the ECU pin. What about the red and black lines in this one? The red wire is the positive electrode of the power supply. Black wire is the negative electrode. Okay, according to the pin wiring diagram. We've connected this now. Then we put this plug again. Connect with our device. Host, we need to connect the bench box. And then plug it in here. Then plug this 12-volt power supply into it. What about on our line? It has a switch here. Before we read, can we open this before we read it? As for the device, there will also be a prompt turn on the power to turn off the power. This is the switch. Next we operate on the software. Select Connect. This device. What about the software? We need to connect to the internet. You can't operate it without the internet. What about this in English? It means to connect to the network. Okay, keep the ECU powered on. Now let's turn this power on. Then click OK. Okay, now what about the software? It has been connected to our ECU. So just these. None of these options in gray can be clicked. Now it's black. It's ready to order. Okay, so what does all this mean? This refers to the meaning of reading all. This refers to reading external flash. This refers to reading internal flash. This refers to reading EPROM data. So what about writing? Write all. Write to flash. Write EPREM. So let me just show you how reading flash works. Data. We just need to choose this option. Click directly on the red flash. Then an interface pops up for us to save. We save it to the desktop. You can create a folder. Then the folder name med. The 27th of January 17, the model of our computer version. Then open. And the file name is flash. We will save the data as flash. Then save. Next, the device is starting to read. Good device prompts to keep the cool power on. This one of ours is open. Then click OK. OK, read over. Power off. What about we turn the power off? Click OF. F is closed, O is to open, then click OK. Then this flash was read successfully. Next we read the EEPROM data. Click. And save the EEPROM. Reading now. Prompt to keep the cool power on. Let's turn this power on. Press on position. Then the software clicks OK. End of read. Power off. Let's turn this power off again. Then click OK. What about this data? Oh, read successfully. After reading this data, what can we do? So for example, here we're flashing power fault card. We'll cancel the anti-theft. We'll repair data, etc. Then after this data is changed, we can also use this device. Write the data in. So how is it written? So let me show you how this works. So let's say we want to write flash data. We'll click this. Then load the flash data. Open. It prompts for checksum correction. So this is the validation of our data. You can click yes or click auxiliary. Because of our data. And now I'm going to show you. How did you write it? It's still original. We don't need to correct this data. Click no directly. If your data has been changed, or it was repaired, that's the data. You need to click this. It needs to be verified. We follow the device prompts to keep the power on. Then click this. Click OK. Then prompt to close the dashboard and wait. We click OK directly. OK, click OK, OK. And what about this piece in the lower left programming corner? Right. OK, let's write flight data. Write successful. Then we will write this EEPROM data. Let's click. Then you need to load the EEPROM data. Then click Open. He will also prompt. For example, when we write data, you'll be prompted to perform checksum correction. If you need to correct this, then you click yes. If you don't need correction, you click no. Keep the ECU powered on. We just follow it to prompt us that this one is OK. Follow the prompts. Click OK. OK. OK, what about this data? It was written successfully. This is how to read and write data as an operation.